Welcome to the channel Data Science Demonstrated. In this video, I'm going to give you a demo of interactive no-code machine learning. Now, this has got multiple advantages. First of all, it allows you for faster experimentation. You can quickly test and iterate machine learning models without coding. It is also accessible for non-technical users to leverage AI for decision making, and it also reduces the development time and cost. The demo which I'll show you is available on my platform experienceddatascience.com, and you can also try it out. In this demo, I've taken the classical problem of churn prediction for a telecommunication company. The data has got various fields such as the customer ID, it has got the customer demographics, the services, as well as the billing information. In addition, it is also called a column churn, which is an indication if the customer has already left or is still with the company. And your mission, if you choose to accept, is to train a machine learning model which will be able to predict if a customer is going to churn or not. Now, before I jump into the demo, let me give you a brief overview of the demo architecture. The demo has multiple components. We have the exploratory data analysis and model training, which is going to be done on the training data. And then we are also going to do model inferencing and explainable AI on the scoring data. First of all, we will do exploratory data analysis of the target, which is our churn column. And this will help us determine what accuracy method to use while training our machine learning model. We'll also do some missing value analysis, which will help us determine what kind of missing value replacement algorithms to use. And then we'll be also analyzing the categorical variables versus the target, which will help us determine what kind of features to select. And we'll do the same thing also for numerical values, which will help us determine the features which we need to select for the numerical variables. Now, once the machine learning model has been trained, we will do inferencing, as well as we are also going to do explainable AI, which is explaining the predictions. Now, let me jump to the demo. You have multiple tabs, and let us first start with the training data. And here you see a sample of training data. As explained earlier, this data has got the customer ID as well as different demographic information, as well as it has got the different services which are used by the customer, the billing information, and at the end we have the column churn. And if the value is 0, it means that the customer has not churned. And if it is 1, it means the customer has churned and left the telecommunication company. Let us now do the target analysis of the column churn. And here you can see that the number of people who have not churned is much more than the people who have churned. So this means that this is an unbalanced data set, and we are going to use this information while we are going to do machine learning model training. Let us now also analyze the missing values, and here you can see that there are no missing values, which is a good indication, and this is also going to help us to determine the machine learning model steps which we need to make. Let's now also go into analyzing the categorical variables versus the target. So categorical variables means all the non-numerical variables, and then we are going to analyze it against the target, which is the churn. And here you can see the different analysis of different categorical values. So for example, here this is the analysis of the customer ID, and as you can see that there are lots and lots of customer IDs. So this is an indication that it would be better to leave out the customer ID while training the machine learning model, which will help us to simplify our model training. We can also see, for example, this is an analysis of the variable gender against the target, and you can see that the proportion of the females who have churned with respect to the ratio of females who have not churned is more or less the same to the male. So this means that this particular column gender is not going to much impact the target churn. Now let us also see one more categorical feature, which is the internet services. So here you can see that the customers who have an fiber optic tend to churn more compared to the customers who do not have fiber optic. So internet service is a good indicator of a customer if it is going to churn or not. Right, so now let us go to the same analysis for numerical values. And here I've selected all the numerical values except, of course, the churn, and we are going to analyze it against the target, which is churn. And here you can see the different box plots. So this is a box plot analysis of the field tenure versus churn. And here you can see that the customers who tend to churn have a lower tenure compared to the customers who have not churned. Now, similarly, if you look at some other fields, for example, monthly charges versus churn, and you can see that the customer who have churned tend to pay higher monthly charges. So this exploratory data analysis gives us a good idea of what the data is and what kind of features are impacting the churn. Let us now go into the machine learning. And first of all, our first task is to select the features which we are going to select in the machine learning models. And of course, we can remove churn because that will be our target. And we can also go ahead and select churn as the target. But in addition, we can maybe also remove certain fields. So for example, we saw that customer ID, there are lots and lots of customer IDs. We have seen this in the exploratory data analysis. So we can in fact remove it because it will help us simplify the model. The field gender, as we saw, it is not going to much impact our machine learning model. So probably we can remove it also. But let us keep some other fields and let us also now set the accuracy methods. So as we have seen that this particular data set is an unbalanced data set, so it makes sense to go ahead with this ROC AUC method, which is very useful for unbalanced data sets. We also seen that we do not have any missing values, so we are not going to make specific settings to that. Let us go ahead and train our machine learning model. And in a while, we'll see that the machine learning model has been trained, and the best model is in fact the random forest model, and we have a very good accuracy of about 81%. We also have the results of confusion metrics. So for example, TN, which is true negative, which means the customers who have not churned, and also the machine learning model has predicted not to be churned, are almost about 4,600. Similarly, we have customers who have actually churned, and the machine learning model has also predicted correctly. So this is around 909. So the true negatives and true positives are where the machine learning model is doing a good job. But then we have some instances where the machine learning model is not performing well. So for example, we have 542 false positives, which means that the customer actually has not churned, but the machine learning model has predicted that the customer will churn. On the other hand, we have 957 as false negative, which means that actually the customer has churned, but the machine learning model could not predict it correctly. But overall, we have a very good accuracy of 81%. So let's go ahead and now apply this model for scoring data. So I will go ahead and select some scoring data. And once again, the scoring data has got the same fields as the training data. Now, generally speaking, the scoring data will not have this column called as churn, but I've just kept it for information purposes. It is not going to be used for prediction, but we can then compare it later on with our predictions. Let us now do the inferencing, which is taking all the records in the scoring data and applying machine learning model to that. So here we have all the fields, and then here we also have the prediction. So for example, for the record number 0, we have a prediction that the customer is going to churn. We have a prediction of 1, and actually the customer has also churned. So this is a very good prediction. If you take the record number 1, we see that the customer is not going to churn, which is shown here as prediction equal to 0, and this customer has actually not churned. So this is once again also a good prediction. But on the other hand, if you take the record number 2, we see that the predicted value is 0. It means that the machine learning model has predicted that this customer is not going to churn, but in fact, this customer has churned. So now we can also explain this prediction, and let us now go into the explainable AI, and let us now understand why the machine learning model predicted that the record number 0 has a churn prediction. So here you see an analysis which is also called as SHAP analysis, SHAP. And here you can see an average probability of churn, which is 0.26. So this in fact is because we have seen in the data set that most of the customers are not churning. So we have a very low probability of the customer going to churn, almost about 26%. But for this particular customer, the predicted probability is almost about 98.5%. SHAP is an indication of the factors which lead for this customer to churn. And all these factors are in fact contributing of moving the average probability of 0.26 to 0.98.5% for this specific customer. And here we can see that the factor tenure is in fact contributing to churn, and we can see that in negative value over here, which means that the tenure is less, and we can see also over here that this particular customer has got tenure of just 1 month, and this is the reason why this customer is going to churn. And this is also reflecting of what we saw in the exploratory data analysis. We saw that the customers who have a less tenure are likely to churn. In addition, we also have some other factors over here, such as total charges and contract month to month, which are also an indication that this customer is going to churn. So explainable AI is a very good way to understand the predictions and also understand the workings of the machine learning model. So my friends, hopefully you enjoyed this video. If you want to try out this demo, you can do so on my platform, experiencedatascience.com. In this particular website, you can go to all experiences and then go and click on AI, Gen AI. And here you'll find an experience called as predicting with machine learning. And once you click into that, you'll be able to see the demo which I've shown you. And hopefully you can also try it out with the data which is set up, as well as you can also try it out with your own data and let me know your feedback. And I hope you'll find this demo very exciting, and see you soon in another exciting demo video.